welcome to this session. My name is Mehdi, and it's nice to meet you all from the screen, far from in Toronto, actually. And but my heart beats over there. Then hi, Prague. By the way, thanks to the OpenSSL team for providing this opportunity. Actually, today I'll be walking you through practical lessons, actually lab-based experiences and methodologies for strengthening OpenSSL deployments using SRIDE, attack trees, and compliance strategies under actually FIPS 140-3. Why OpenSSL? Why OpenSSL matters, actually? OpenSSL is everywhere, from web servers, VPNs, mobile apps, and IoT devices. Every single day, yeah, we are using OpenSSL because it's deeply integrated across platforms. Even a single configuration flaw can have cascading effects across multiple systems. We've seen operational issues like certificate mismanagement, weak cipher settings, and actually key rotation failures in resulting that in serious vulnerabilities. As we have some practical experiences like Freak and Logjam, I'm pretty sure that you heard about that, that taught us the legacy configurations, such export-grade ciphers left enabled can lead to real-world compromises. Even today, many production servers still allow weak TLS versions. I'm pretty sure that you're seeing every day, maybe, actually based on the evaluation experiences or compliance procedures. So it's crucial to address these misconfigurations before they become incidents. Here, we can see, the some wrongs with misconfiguration of OpenSSL. Actually, this slide serves as a bridge. We can see here, and the key message is most vulnerability don't come from OpenSSL itself, actually, but from how it's configured and maintained. This means that misconfiguration and don't doing the hardening and security baseline could result the some vulnerabilities and attacks in the on the infrastructure, software, and the etc. Actually, understanding where things go wrong help us structure our threat model effectively. We need to know more about the misconfigurations and mismanagements of some modules like OpenSSL to do the best threat model in the network. Why? Okay. Why we should do a threat model based on OpenSSL systems? Actually, threat modeling is about the anticipating attacks before they happen. I'm pretty sure that you know already. And we'll focus on two main tools now in this lecture, SRIDE and attack trees. Actually, SRIDE helps to categorize threat into 6 dimensions: spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. Meanwhile, when we are talking about these classifications, attack trees is helping us to visualize attacker paths and prioritize defenses based on impact and likelihood, the probability of attacks, actually. Here, based on the this simple slide that we are seeing now, collaboration is essential and make this procedure repeatable and team-based experiences. So we are seeing easily that we should do all steps in order to get the actually the best result of threat modeling. And the crucial role of threat model in the security evaluation process. Some transitions. Here we're gonna apply S-right model on OpenSSL actually. Let's apply it. Spoofing, like what? Like with weak certificate or hostname validation leads to man-in-the-middle attacks. It's some like of spoofing issue. Or for tampering, we can have unverified or tampered binaries are as a major risk in the threat modeling. Repudiation, like missing TLS logs, make it impossible to trace incidents. Information disclosure, like weak ciphers or certificate chain issues. As a result of that, we face leak data. The other one, denial of service, flooded handshakes and renegotiation abuse, actually. And the last one is elevation of privilege. That's it's related to the API misuses or insecure key handling. But by this mapping, I mean S-right to OpenSSL components, we can pinpoint both technical and operational controls on the evaluation procedures. Here, I'm gonna show you that the real experiences in the world that they happened before, and we can see here the CVE number, definitely here, that, as I mentioned before, it's because the misconfiguration and mismanagement of OpenSSL components on the software infrastructure or etc. So this is the actually emphasizing on the concepts that we discussed before. You can see here actually the S-right steps, OpenSSL case examples based on CVE. Most of them are based on CVE. And what should we do, what to monitor actually, and quick mitigation, because we are talking about the compliance and evaluation process. For your attention. Actually, in this slide, we are seeing a kind of attack tree example. Here's actually the attack tree with goal of compromising TLS confidentiality. At the left hand, you are seeing that attackers have three main paths. Number A, downgrade attacks that force negotiation of weak ciphers. Number B, certificate forgery and man-in-the-middle attack interception. And C, key theft from mismanaged environments. Actually, we are seeing this path at the left hand, and each branch shows layered opportunity to defend. And we can see at the right hand what happened based on probability and the formulated risk based on the, as I mentioned, likelihood and impact of the actually vulnerabilities in the network. And there are some wins, quick wins, that could lead us to the best way of defense. They are including disabling weak ciphers, enforcing a strict certificate validation, and securing private keys. So this is the actually practical way of using the attack tree in some real case. The next one is one case study that it's happening as a result of weak cipher configurations. Again, here, let's look at the real world case here, as I mentioned. A system experienced a handshake failure after an update. Let's see this example in this way. We had an update before, and now we are facing a failure between the, for example, load balancer and backend, for example, server backend. What would be the root cause actually? Cipher mismatches between load balancer and backend server. This is what we are seeing now. The fix involve unifying cipher policies and performing a stage rollout. Let us think that we're not gonna use rollback. We are just using rollout. The lesson is here, inconsistent cipher policies can hurt both security and availability. Some guys here are telling that availability is the one part of security, and yeah, they are right. But in a real world, sometimes people think that we should be available every time, and in contrast, we cannot have sufficient security. So let us think that security and availability are separated concept here, and we can see the cipher weaknesses could hurt both security and availability. The other one is consistency plus strong ciphers can lead to reliability and safety as a result of the previous sentence. So in this, it is actually it's a easy sample of the real case study in the network that I compacted it here, and I'm gonna show the result of the this incident in the actually infrastructure. How we should respond to the incident that they happened as a result of crypto systems. Here, we follow 4 phases as a practical way. The phase 1 is detection. Actually, we have to identify TLS anomalies and chain changes here. We should do that. The next one is containment. We have to isolate affected nodes and disable fallback mechanisms. The third one is eradication. We have to rotate keys and rebuild affected binaries. And the last one is verification. We have to conduct comprehensive scans and audits in a fixed duration, and we have to do that based on the plan and schedules. So based on that, we can make sure that everything in the network could work properly, and we can make sure that we have sufficient stability in the network. Here, I'm gonna show you the, actually, I wanted to be more obsessed about the verification, and evaluation on the critical infrastructures based on this enforcement on some kind of platforms like them. Actually, FIPS 140-3 validation is a crucial and actually important way for any organization that they are using OpenSSL in regulated environments. For example, healthcare systems, financial systems, and so we are seeing that some other industries enforce the solution providers and developers to implement the FIPS modules and the some related security option based on that on the system further OpenSSL modules. Actually, we are emphasizing 5 areas here, as you can see in this slide. We have to use only validated crypto modules and track certificate numbers. It's essential based on actually FIPS and FIPS policies. Number 2 is manage key life cycle carefully with secure storage and rotation. Number 3 is plan patch rollout. Patches actually here, patches can invalidate FIPS validation. Number 4 is maintain a strong documentation and audit trails. And the last one, number 5, is establish operational planning with clear roles, separation of audits and duties based on that, and compliance oversight. Actually, this ensures both security and regulatory continuity. If you remember, we mentioned that security and availability, and now we're gonna emphasize on security and their regulatory policies, because as I mentioned, some critical infrastructures need to make sure that there are some baselines and at least the minimum requirements of security are already implemented in the network or infrastructure. What we should do at the next step, we need to have a practical and hands-on actually baseline and instructions to follow the security baseline on the infrastructure or platforms or networks, etc. First of all, we need to automate the procedures in the evaluation procedures and in the network. Actually, automation is the best defense against theft. I'm pretty sure that you confirm this phrase. We need to implement nightly as a schedule, nightly TLS tests with, for example, OpenSSL S_ client as a prompt here. We need to create software compatibility metrics to ensure inter-service consistency, because we need to monitor, for example, at that example that I mentioned before, load balancer and backends and providing service to the clients. The other one is actually use automated certificate watchers for expiry alerts. Unfortunately, we are seeing that there are some platforms that they are using revoked certificates, and it's gonna be like damage and spoofing in the network. The other one is deploy lightweight scripts for canary rollout before production changes. We need to monitor and make sure that everything is going well. Before that, we do updates and providing the new version of whatever that we're gonna deploy on the network or infrastructure. Actually, based on this slide, we can say that together these steps bring continuous assurance in the network. We know that business continuity actually is the most important thing in the world, because if we're gonna for example, provide some solutions, softwares, infrastructures, and AI-driven solutions even. And if they don't work properly, we cannot get the results that we want. So the main aim is that continuous assurance about the networks and infrastructures. So we're gonna emphasize on the steps here. What would be the next steps based on the discussion that we had till now? Let us summarize all things that we reviewed. We need to threat model early before doing anything else in the network or infrastructure. We need to basically implement threat model in the network, because sometimes people think that threat model is like a luxury thing in the network, and it's like a wasting of time and energy, but actually it's not. We need to do threat model early, and we should automate validation and provide the actually some actions to prevent the attacks and exploit the potentially vulnerabilities in the network and infrastructures. We need to follow some standards like FIPS, NIST, ISO, and the documents based on that, because they are providing the minimum requirements of security requirements based on security functional requirements, security assurance requirements, and sometimes providing the requirements of life cycle of products, security, how to implement the security mechanism to make sure that everything is going well. So we need to follow the standards based on the, let me put it this way, that we have to follow standards to make sure that at least we implemented the minimum requirements. And we have to do more. I know that just we're gonna make sure that we implemented the actually minimum requirements. And let us share playbooks across team for faster security culture. Sometimes we are seeing that developer are working on the isolated island, and it's not good for the team to they work without any good relation. They have to know more about the security baseline, security mechanism, and let us share the playbooks and security baseline and the instructions across the team to increase the knowledge and approaches, enhance the approaches about the security. And ultimately, at the end, I'm gonna say that resilient OpenSSL systems, actually, based on this conversation, require proactive design and operational discipline. As I mentioned, and it was the first sentence that I said, You know, some crucial vulnerabilities and attacks don't based on OpenSSL. Actually, it's based on actually misconfiguration, mismanagement, and you know, lack of secure implementation of these modules. So yeah, these steps would be the next steps, and they're gonna be as a, you know, mindset of organizations, and yeah, it could be helpful. And what we can see in the future. In the future, as we can see now that we can see the you know, the changes based on 1 second. So looking ahead, actually, we can see 3 steps that, in my opinion, will shape the future of OpenSSL security. Based on the references and OpenSSL approaches and the some standards organization in the world. First of all, it's TLS 1.3 adoption, that it brings faster and more secure handshakes and easiest way to configure. But actually, it also introduces new downgrade challenges when all their systems still depends on TLS 1.2. That's as we know, it's not enough secure. So the second one would be the concept about the post-quantum cryptography. That's it means that quantum computing will eventually break today's actually public key algorithms. So we must start preparing our transition plans, and we should actually follow this instruction. As we know, OpenSSL is already testing hybrid models with upcoming NIST-approved algorithms like Kyber and the other one. So it means that future updates actually will include new cryptographic, primaries designed to resist quantum attacks, and it should be considered in the evaluation procedures. And the third one is supply chain security. We are seeing that new concept like vendor audits, it's nowadays is a crucial importance actually. So verifying built-in integrity and dependency trust would be crucial and would be critical, as I mentioned. So OpenSSL is moving toward signed builds and reproducible actually releases to help the detection of tampering or injection in the build process. So I hope that I be in the correct time. So thank you, everyone. I appreciate your attention to my lecture, and I'm more than happy to be here, even I'm far from you. So this is my email address to be connected, and my LinkedIn address, and it would be my pleasure to be connect with you. So I'm here to answer the question if there is any question. Thank you so much, guys.
So while the audience is thinking of some more some questions for you, I can start with one. So one of my questions, and I think one of the issues that keeps so part of my role in OpenSSL is I'm a member of the Business Advisory Committee, and there they deal with small businesses and large businesses. I'm not in those communities, but I get to hear all the stories that they tell. Probably one of their pain points that they deal a lot with is having to deal with supporting older and I'm going to say deprecated end-of-life versions of OpenSSL. So in your strategy where you talk about like sharing playbooks across teams, I've heard other organizations can struggle with that because when you're sharing, they may not really be, you might be using OpenSSL versions that are several years apart. And so sometimes sharing any kind of results or configurations across those version differences can be a real big pain point. Do you see that as a big issue in your position and in your work when you do this kind of threat modeling, or would you comment on that?
Actually, yes, you're right. Based on my experience over 17 years of security evaluation as a lab manager, I can see most challenges between the team members. When you are, you are playing, as an evaluator role. You may face some conflicts with the others, like developers, because they don't like to, implement your advices. They think that they know enough about the systems that they are working on that. Yes, I mentioned that we should propagate the instructions in the network, but in the team members across the team. But yes, I agree with you, because yeah, there's a challenging topic actually, and based on my experience, I think that they people and teammates sometimes think standards and security baselines are something so it's not useful, and they don't want to implement them actually. But I think that knowing more about the vulnerabilities and the effects of them actually, and knowing more about the lack of modern cryptographic supports in the platforms, and actually some topics like that could help us to be connected to others in an efficient way. Sometimes, for example, a system are using, for example, this is an example, a system using outdated OpenSSL versions, that it could lead to fail to meet the actually security and compliance standards, and such like PCI, ISO 27001, and NIST, for example, and it's required to be updated, libraries and cryptographic modules. So yeah, I think that at the end, we should to provide the standards mechanisms, as I mentioned, as a minimum requirements in the platforms, and yeah, we should we should try to increase the team knowledge about this. And I think based on two options, we could get more benefits and take advantage from the infrastructures. Yeah. I hope I answered.
Yeah, no, I think it's
I
an
did answer your
interesting.
question. Yeah.
Oh, thank you, thank you. It's a great answer. I think it's really interesting that a lot of those clients kind of view OpenSSL as it's kind of a tool, like an ends to a means for them, and it's not like, so it pushing them to make changes, and it can be very challenging. I understand. Thank you for the answer.
Thank you.
Any other questions for Mehri today? Anything? All right, so if not, let's please take a minute to thank Mehri. Thanks again for the talk. We appreciate you taking the time to join us remotely from Toronto. If you're ever in Rochester, New York, please, I'm just across the lake from you, so feel free to look me up. So,
Sure. Okay, sure, for sure. Thank you so much. Thank you. Actually, OpenSSL, I'm gonna thank Hannah especially because she was very, helpful. And yeah, thank you so much. Thank you, your team, and enjoy the rest of conference.
Thank you. Let's thank that speaker one more time.
Thank you. Thank you. Bye.